This is the load, current, this is voltage, output voltage. So typically, ideal voltage source will be like this. It is independent of the current that you draw. But the non-ideal voltage source will go this way. And this slope is called the R0, which is delta V by delta IL, and that's called as the output impedance. My handwriting is bad. You can make sense. Output impedance. And ideally, output impedance should be 0 for a voltage source. Okay. As against this, what is the current source? All of you have done Thevenin's theorem and Norton's theorem in your second year, right? So current source represents is like this. Ideal current source is the value of the current is independent of the output voltage, and therefore a non-ideal current source would deviate itself and look like this. Okay. So slope of this is also known as output impedance R0, and for a current source the output impedance has to be infinity, and this has to be for the voltage source it has to be 0. Is this clear? Answer? So if a voltage source is represented by voltage V in series with the R0, and this is your load that you want to put RL. So you have a R0, R0, and you can see that if there is a voltage V, this voltage is not going to be V, it is going to be VL. This is going to be V source minus IL into R0. Is that clear? Let's see typical behavior of a voltage source. What happens in a current source? How do you represent a current source? Current source is represented by a symbol like this. This resistance is there called R0, which is supposed to be infinity, and you have a load resistance which is coming here, RL. Now the current is supplied from this or taken from here. This is called pump. If it is only one direction, it's called source or sink. If it's both, then it is in this direction. What happens here? Some current flows through this, which is I0, and some flows through this is IL. So current supplied by this I source is going to be sum of I0 plus IL. If R0 is infinity, this term is going to values to 0, and I source is equal to IL. Like here, if R0 is 0, you are going to get VL is equal to Vx. These are all practical considerations. So you can either have a voltage excitation or you can have a current excitation. In case of the instrument which I am going to refer now is the NPD monitor or a male impedance monitor. So I am going to use this method, and I am going to use a pulse excitation and not a DC excitation. You can use this source either in a pulse mode or you can use this source in a DC mode. There are advantages of pulse and the DC, which we know that if you use a pulse mode, the common mode signals can be removed, can do a frequency selective detection. Whereas if you use a mode which is the DC mode, then there are errors like ambient, whatever we had seen. Is that clear? Now how do you design a current source in the first place? And how do you design a voltage source? Let's not worry about voltage source, all of us know how to design a voltage source. Let's talk about current source design. Can I rub this off? That's it. Thank you. If you are through with this, I think we can go to the design of a typical power and current pump. So I want to design a current which is independent of the load resistor. Remember, it is not constancy with respect to time, it is constancy with respect to the load variation. If the load is constant, the time is implied into it. Okay, let's take two simple configurations of op-amp. This configuration is, if I remember right, if I given a gain voltage here, what's the output? First of all, what is this configuration? Let's assume that this is R1. This is R2. No. Let's give it R3, R2. Maybe R1, R2 here and R3, R4. What is the output here? In terms of gain?
Modulation ratio.
What is the configuration of non-inverting amplifier? So what's the gain? Gain is 2. So 1 plus ratio of these two resistors. So gain is 2, right? So this is going to be 2 times the V plus. What is V plus? It is 2 into V in by 2. So that is going to get divided. If RTR is the same, V plus is going to be half of this V in. Is that correct? So what is output? Output is equal to V in. Is this clear? This output is same as V in. Now I have got a resistor here. I'll call it R control. And I'll put a buff, I'll put a circuit configuration. And I'll connect this line over here. Now tell me what the modification that will take place in the formula. You will find that if this is where you are going to connect your load resistance RL, and this is going to be a ground line, then this voltage is V0 or VL. Is that clear? Well, the current is going to flow this way or this way inside the load. I'm trying to design a current source, remember. So what happens is, you have a voltage here, which is V in. Okay? Will it remain V in now? It won't, because I have connected this VL over here. It's a buffer. So it is V in plus VL by 2 by superposition theorem. If you use the superposition theorem, this is going to be, this output is going to modify itself and it will become V out is going to be V in plus VL. VL is here. This potential is not going to be V in now, it is going to be V in plus VL. Do you agree with this? Or no? Why? Because earlier I connected this point to ground, I am connecting it to this. This is a feedback I am taking. And so the superposition theorem means only either this or this source at a line. So it's going to be V in plus VL and this is going to be VL. What is the voltage across this now? Is V in. Whatever voltage I give here will appear across that R control. So what is the value of the current going to flow out here? Will it be decided by RL? No. So this current, which is I control, is going to flow like this and also flow here. But typically for op amp, the input bias current is close to 0, so everything is going to flow out of the circuitry and therefore it is going to the high impedance. It's not low impedance, it's high impedance. And therefore, now the value of the IL, you can tell me what is the value of IL. IL is going to be, yes, V in by R control. Is that right? The value of the current in the RL is not decided by the RL, but it is decided by this resistor, R control. This is how the current is decided. So typically you will represent this as a black box where the input is V in, okay, and the output is current source like this or this way. Now, if V in is positive, then the current flows out. If the V in is negative, the current is going to flow in. So if you connect a resistor here, the voltage across this resistor can be positive. If the voltage is positive, it can be negative if it's negative, but it is not the same as this. The value of the voltage here is going to be this I control into RL. So typically for a constant voltage source, we talk about the voltage compliance of a constant voltage source. So similarly, in a constant voltage source, we talk about a current compliance of a voltage source. In constant current source, we talk about voltage compliance of a current source. These are two opposite terms. If it's a current source, we see what is maximum permissible voltage that can be developed here. And in terms of voltage source, we say what is maximum possible current that can be delivered by the output of the op-amp. So typically for a plus minus 12 volt power supply, what is the compliance level? What is the voltage compliance of a current source designed using a plus minus 12 volt power supply? That's the exercise you can do it for yourself. It is not plus minus V supply. Neither it is plus minus V supply by suggestion. It is the V supply minus the V in. That gives you the positive voltage compliance and the negative voltage compliance. These are the terms which you have to get yourself familiar when you are trying to do design of this. Okay, fine. But this is everything is okay. So I'll make a slight modification into this and I'll make it a programmable current sum pump. So what I'm going to do is I'm going to use a current voltage source. Okay. Oh, sorry. I'm going to use a PUGA here, circuitry, which is nothing but and a switch here, and give V in here, and this V in will be connected here. So this potential now will become positive V in or negative V in depending on the switch position. If the switch is open, you will get positive. Switch is closed, you will get a negative. So you are changing the sign of the voltage, control voltage, by this switch. So you require one bit for controlling this. And the last stage which I'm going to put here is your port, any port, microcontroller, followed by a latch, LADCH, and then a D to A converter. And this output, I'm going to give it to an op-amp, which is current to voltage converter. And this is what is going to be fed here. Now what is the data here? B0 to D7, and one more port line here, that is D8. You have a digitally programmable foreign current pump, where the magnitude is controlled by the 8 bits of the port line, and the duration is controlled by this bit. So using 4 op-amps and one D2A converter, you can actually have designed a digitally programmable current pump, which can be used to decide what is the current that should flow into the load. So far so good. If no questions, we'll move from here onwards. So all these things is going to be again represented by a black box, which you may call DC, digitally programmable constant current pump. The input is 8 bits for magnitude and the 9th bit for direction. And you're going to get output here. Imagine at this output, I connect a mercury strain gauge. Mercury strain gauge is an elastic tube with the mercury put inside. And now you know the property of a resistor. Okay. This is the length of the conductor L. This is the area of cross section A. And the wires connected, the platinum, the gold wires, G1 and G2. I connect this as a RL. What happens if I stretch this, the length is going to increase and the area of cross section is going to decrease. It's a mercury filled elastic strain gauge. It's an electric strain gauge, elastic strain gauge. So if there is I have to make a circumference measurement. For example, if I tie that around this glass, if I take a mercury strain gauge and put it around the glass or a bottle, any one of them, you can find there is a different circumference here, there is a different circumference here. Am I right? So I'm trying to measure the grit, GRIT, grit is the circumference. So what happens in the male impedancy tester is that this is wound over the penile region of the male at the base and at the tip, and we monitor what is the circumference of the penis during the 8-hour sleep of a male patient. Now you must be knowing there is a term for nocturnal penile tumescence, NPT. It's a very common phenomenon which takes place in as a young child, as 2 months old child. Also will find that the swelling of the penis when he wants to urinate. It happens during the male age, also it happens during the old age of 80 and 90. This has nothing to do with the sex. So if the NPT signal is proper, the nocturnal penile tumescence signal is proper, then we say he may be important or may not be important. So there are 3 types of impedances which come as organic impedancy, the psychogenic impedancy, and cultural impedancy. We are not going to the details of that. But to treat a patient, and this is a typical problem in the childless couples, that the wife is not able to conceive a child in spite of having the physical relationship with the husband, because the male is important. So rather than looking at the horoscope of the husband, you would look at the test whether he is male or, even if it is a male, whether it is important or important. And there are surgeries done by Dr. Rupin Shah here, the world's only microvascular surgeon who does penile surgery and ensures that he is a normal person and not an impotent person. Now, many times when you have operations or you're a diabetic person, you always develop a male impotency. If you have a marriage which is against your wish, it develops a male. The man doesn't like the wife, so he develops a psychogenic impotency. Or in Indian culture, we don't have relationship with other lady other than your wife. That's called cultural impotency. So all these impotencies can be categorized, and the person can be treated basis of what type of impotency is suffering from. And today, more than 10,000 couples have been able to get the child by surgery done by Dr. I'm not advertising for him, but he is a scientist who has really worked. He's the top gold medalist here in the University of Bombay. So only world-known surgeon for microvascular surgery of penile region. So this is just a brief introduction I gave about what is the male impotence monitoring. This is also known as erectile dysfunction. All these diseases finally lead to a heart attack. So don't take this as a lightly. If somebody's husband has a male impotency, treat him well so that he lives a longer life. There's a phrase called bedroom to boardroom and boardroom to bedroom. If you're inefficient in the boardroom of your organization, you're going to be inefficient in your bedroom also. Vice versa, if you're not good in the bedroom, you're going to reflect in the boardroom. So don't carry your problems from home to office and office to home. With that, I think with the second talk is over. We almost 15 minutes at our disposal. I mean, we'll have to open our discussion. Any questions you can ask? Otherwise, I can take a liberty of closing a little early. I have got more than about 29 GB of reading material. That's why I don't know whether you can give it in one CD. I'll leave it to the organizers to decide what is to be done. Coming back to the ISO 13485, if I'm supposed to design this instrument, I have to document the procedure which I use for designing this instrument. I have to give the maintenance procedure, I have to give a software. If I'm using a software, the software has to be validated. And I must write down who was the person who did the software and what is the typical algorithm he has used. So instrument design, it was easy very long time back, but today with ISO 13485, you have to document software. And it takes more time to document a software rather than developing a software. So 13485, you have to be serious about this 13485. Of course, it's very boring, let me tell you. If somebody wants to read 13485, you would rather give up designing also. It's not interesting at all. There are rules and regulations which you are supposed to know. Unless you do know them, unless you state that this impotence monitor has been designed by XYZ with these design criteria, they will not allow you, they will not give FDA approval, they will not give approval to sell it in India also. Any questions? Today, there is a stigma attached to people who are impotent. So we have designed an instrument which can sit in the pocket like this, okay? And it monitors your penile region diseases over the time, either in the sleep property or during the day. That's all. And then you just go to a doctor, give him this rubber, and then he will do all the analysis. Normally, you are supposed to get 4 episodes of timsins for any male, whether it's a child or the adult or the normal person. And not only that, not enough. The subsequent test called VGDD test and all. And only when both the tests are through, the couple is expected to have a child, not otherwise. Okay. In US, the maximum number of impotent patients are the cops, okay, and the army soldiers. They work under extreme stress. They are away from the family and they don't know whether they're going to go back alive or dead. And another problem of male impotence is they become senile. It's like that's why you find a number of rape cases and the murders subsequently which happen in the US society is because of the male impotency. And they are trying to address this problem by applying psychologist and that's why every male soldier is sent back to his home every 2 years from the war. Okay, I think with this we can stop for the day. Thank you very much.